Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into an 11th grade topic, solving trigonometric equations. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below. So use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what you see today, or even you want homework, you can always put it in the comment box below, or visit my Facebook page, Tutor Me Sempai, and tell me all about it there. At the end of this video, I'll be linking my 11th grade playlist, in which I cover a lot more topics. So if you're interested in that, make sure you stay tuned. This video is going to have 3 parts, so leave a like, smash subscribe, and let's get started. At this point in time, if you have your unit circle, you should be able to answer something that looks like this. All you would need to do is take your angle, find it on your unit circle, and for the trig function you're looking at, figure out what is the value. So in this case, cosine of pi over 2, if we look at our unit circle, we know that that's going to be 0. However, we want to do something different today. We want to solve our trigonometric equation. That means we want to do the reverse of what we've been doing. So instead of finding a value given a particular angle, we want to find all possible angles given a particular value. So it would look something like this. Cosine of x equals 0, and we need to solve for x. What does x equal? Unlike what we've been doing previously, which always gave us a one-to-one relationship between our angle and our value, we're going to have infinite many angles for a particular value this time. And that's because our trig functions will hit the same value multiple times as you do 360 degrees. So you have to account for that. What that means is that we won't have just one answer. We need to actually write this answer in the form of an expression to capture all possible angles. However, you may not have to write all possible angles or even that expression if you're supposed to focus on all the angles within a particular range. So let's focus on the range 0 to 360, or in this case 0 to 2 pi if we want to do radians, and find out what angles would make this true. So if we're going to focus only on 0 to 2 pi, we already know what one value is supposed to be. We know that because we just looked at it. So we know the first value of x is going to be that pi over 2. That was what we had when we began this. However, is there another value of x in this range of 0 to 2 pi? Yes. We know that next value is going to be 3 pi over 2. And these are going to be the only 2 values of x in this range that when you plug it into cosine, you're going to get 0. But let's say we didn't want to focus just on this range here, and we want to find all possible values for our x that makes this true. How do we write our answer that will allow us to capture everything without having to write everything? Well, notice, on your unit circle, this pi over 2, you're going to hit this spot every time you go 2 pi. Every time you go 2 pi around your unit circle, you're going to end up in the same spot. And it doesn't matter if you go a positive 2 pi or a negative 2 pi, you're always going to hit the same spot. The same is true for this 3 pi over 2. Every time you go full 2 pi, it doesn't matter, positive or negative, you're going to end up in the same spot. Thus, you're going to always have this 0 for every 2 pi you go from this spot. So we can write an expression that looks like this. So we have a pi over 2 there, and we have a 3 pi over 2 here. Now, pi over 2, we said every 2 pi, right? So plus 2 pi times n, where n is just going to be an integer. It could be negative, it could be 0, it could be positive, but it's just going to be an integer. The same thing is going to be true for this, 3 pi over 2. Every time you go a full rotation, all the way around your unit circle, landing back here, you're going to be 0 for your cosine. So when you add 2 pi for every n, every integer, this is also going to be an answer for you. So notice your x has this type of look. And in most cases, this will be all you would need to do. However, this is a particular case that's a little bit special, only because these are actually 180 degrees or pi distance away from each other. If you start at pi over 2 and you go pi or 180 degrees from there, you're going to end up here. And if you go another pi or 180 degrees from there, you're going to end up here. So if you're going to go 2 pi to end up here, and this one is going to go 2 pi to end up back here, you can technically cut this in half and remove one of these to simplify your answer. Now, that's not always going to be true. You have to be pi away from each other, pretty much polar ends of a unit circle. This is going to be true because they're polar ends of the unit circle and they both equal 0. So because of that, we can actually write this x answer as such. Instead of having both of those, we can do pi over 2 plus, instead of 2 pi, pi times n. Because if we go 1 pi, if n equals 1, we're going to be at 3 pi over 2. So we already take that into account. And if we're going to go another pi, we'll be back at this pi over 2 spot. And another pi, we're going to be back at this 3 pi over 2 spot. Maybe not the actual angle, but the spot. So you see, this actually captures all of our angles. So this is one way you can abbreviate your answer, but this is not going to work for all of them because this is a special case. They're on polar ends of each other, pi distance away from each other, and the answer is going to be the same at 0. So let's jump into our first actual example for today, and let's see something a little bit more complicated than just cosine of x. So for our first example, we have cosine of x plus the square root of 3 equals negative cosine of x. And we want to find all possible values in degrees for this x. So we have to solve this. And we're going to solve this the same way we do any type of equation. Let's group together the things that are similar and let's move the things that are not. So we have cosines. Let's put all of those on one side and then put this square root of 3 on the other side. So when we do that, we can rewrite this as such. Cosine of x, we're going to add this cosine to both sides. We're going to therefore cancel that out. Cosine of x equals, we're going to subtract this square root of 3 and it becomes a negative square root of 3. So we're going to subtract it from both sides. And that's pretty much just trying to make sure all the cosines are on one side and the radical is on the other. Now we can combine the like terms essentially, and we're going to have 2 cosine x equals negative square root of 3. Now we have to get cosine x by itself. We're going to divide both sides by 2. Therefore, we have cosine x equals negative square root of 3 over 2. So at this point in time, you can look at your unit circle, but we want to find all possible values in degrees. Remember, we stay in degrees, so here's a little note that we are in degrees for this question. All possible values of x that makes this true. Now, if you have the unit circle that you can reference or you remember your entire unit circle, great. But if you don't have your unit circle or if you don't remember your unit circle, you can actually use your reference angles if you remember your first quadrant to actually help you figure out this answer. Now, if you have no idea what a reference angle is, no worries. I have a video on that. You can find it right up here. Check it out and you'll see how cool it is and how it can actually help us do what we're about to do in just a moment. So if our first quadrant looks something like this, I know that 30 degrees is going to be the reference angle that I'm going to need. But which quadrant are we in? Because this is clearly negative, whereas in the first quadrant, it's not negative. So which quadrant has a negative value for our cosine? Well, it's going to be in either quadrant 2 or quadrant 3. And I know the reference angle was 30. So in quadrant 2, the reference angle of 30 means that we have a regular angle of 150 degrees. If we're in quadrant 3, a reference angle of 30 means that we have a regular angle of 210 degrees. And that's simply using reference angles. I know that because of how reference angles works and the formulas of the reference angles, I'm reverse engineering them. Once again, if you have no idea what I just did, no worries. Just use a unit circle or check out my video on reference angles. However, these are going to be the only two angles on our unit circle between 0 and 360 degrees that has a cosine value of negative square root of 3 over 2. But we want to find all possible values, not just in that range. So we're going to have to add, and now we're in degrees, so it's going to be a full 360 degrees times your n. Remember, n is going to be your integers. So these are going to be your integers here, where it could be positive, negative, or even 0. And the same thing for this one, plus 360 degrees times n. And this is going to be our x. However, unlike the previous little example we did, these are not going to be polar opposites, so you can't simplify these. This is going to be one and this is going to be another. These two expressions make up all possible values for this particular x. Let's look at one more example with radians this time. So in our last example for today, we have 2 cosine x times sine x equals cosine x. Now this looks a little bit different, a little bit much, but you can still do this. Just take it one step at a time. And you want to solve this for what x makes this true. All possible values of x in radians that makes this true. Now before we begin, I'm going to tell you what not to do when we're solving this. Now you might be tempted to divide out this cosine x, right? And if you were to do that, that would go away and you would be left with 2 sine x equals 1. And that in itself doesn't look like improper math. However, what this does is it eliminates some values of x that you're not solving for because you're not taking into account cosine now. Cosine is no longer part of this equation, so therefore every value of x that would make this true for cosine is not found. And we want to find all possible values. So we can't divide out that cosine because we're going to be getting rid of values that we want to find. So instead of getting rid of cosine that way, let's combine everything and do some factoring. So you'll see what I mean in just a moment. We have 2 cosine x times sine x equals cosine x. Let's get everything over on one side. So we're going to rewrite this as 2 cosine x sine x minus cosine x equals 0. Now we see that we have cosine x in both parts. So we can factor out a cosine x. So we have cosine x times 2 sine x minus 1 equals 0. Now you see that we have cosine x times this equals 0. That means that either cosine x equals 0 or 2 sine x minus 1 equals 0. We have two equations that we can solve for. Previously, if you would have canceled out that cosine of x, you only looked at one of these. So you see, you would have missed all the possible values of cosine x. But now we can take them into account. So I'm going to break them up this way here. So this is going to be a sine. We're going to pretty much solve for this. So sine x equals 1/2, right? We get sine by itself. Sine x equals 1/2, and we have cosine x equals 0. Now, how did I get here? Well, remember, we had 2 sine x minus 1 equals 0. We get sine x by itself. That's 2 sine x equals 1. Divide both sides by 2. You're left with sine x equals 1/2. Now, if we can solve both of these two equations, we can find all the possible x's in radians that make this true. Now, this cosine x equals 0 looked like something we talked about earlier. Actually, in our very first part, we tackled this very thing. Now, what values, if you remember, made this true? Well, this is going to be x with a pi over 2 plus n times pi, or pi times n, doesn't really matter. And remember, n is going to be your integers. We already discussed that. Now let's go here. Here we have sine of x equals 1/2. Where on our unit circle does sine of x equal 1/2? Now, once again, if you know how to use reference angles, you can use your reference angles now. And going back to our first quadrant, we know that we look something like this. I did it before. I'm going to do it one more time. Now we know that in our first quadrant, we have something that looks like this. And we know that sine x is going to have that positive 1/2 when x is pi over 6. However, this is not the only place sine x equals a positive 1/2. Using our reference angles, we need to know where else on the unit circle is there going to be a positive 1/2. Well, that's going to be not only in quadrant 1, but in quadrant 2. And that reference angle of pi over 6 is going to be found where in quadrant 2? Well, it's going to be 5 pi over 6. And there's no other place on our unit circle that has a positive 1/2 for sine. However, we don't want to just stop at a unit circle. We want to find all possible values. So we're going to remove this unit circle and we're going to start with these two values and we're going to add in our 2 pi n. So we're going to have x is going to equal this pi over 6 plus 2 pi n, and it's going to equal 5 pi over 6 plus 2 pi n. These are all going to be values of our x that makes this true. So when we put all this together, we have three expressions for our value of x that makes our original question true. The first is pi over 2 plus n pi. The second is pi over 6 plus 2 pi n. The third is 5 pi over 6 plus 2 pi n. All three of these expressions will give us values of x that makes this true. And remember, we had all three of these because it can be true for cosine or it can be true for this sine here. So I hope you were able to follow along with today's examples, and I hope you now know how you can solve your trigonometric equations. However, if you have any questions, remember you can always put in the comment box below or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so already, remember to leave that like. It really helps the channel by letting YouTube know that you found the video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework, and I'm hoping to see you again next week. I'm Courtney, this is your playlist, and this has been another session of Tutor Me Sempai.